So this work started last summer at a symposium on geographic imagination systems in Berkeley with David O'Sullivan, Luke Bergman, and Nick Lally. My co-author on this project, Evangeline McGlynn, who made the amazing illustrations you'll see throughout the talk, is currently in Armenia conducting her dissertation fieldwork. And we thought that trying to get Skype and do a live demo of our program on conference Wi-Fi, we're not as brave as you, Anthony, so that we thought that was a bridge too far. So I'll be presenting today, but we are equal contributors to this project. So what do we mean by pseudo-spatial, or maybe more accurately, pseudo-Cartesian charts? So Eve and I started with an observation on current trends in data visualization and the digital humanities, especially for non-cartographers who are arriving with a lot of excitement for spatial data, and then they see the existing tools and they're quickly sort of shunted into two camps. So this is a very reductive critique, but on the one hand, we have the iron grip of Web Mercator and the pin map, no matter how well dressed it is. And then on the other side, in the land of pure data relationships and not really attempting to show spatial data, we have things like network visualizations, which can be very effective, but we do lose that spatial being special. So without the kinds of advanced cartographic chops that we have in this room, these are sort of the two directions open to tell story with data. And we're really thinking through, when we have our idea of the use cases for this, we're thinking of people like journalists, people in other fields who have data that they really want to put into a map, and then they get 100 pins on the United States, and we get the kind of XKCD heat map problem over and over again. Of course, our whole line of thinking was inspired by some of the first quantitative revolution and some of the major works, especially some of the nonlinear distance experiments of people like Torsten Hagerstrand and Bill Bungey in theoretical cartography. So Eve redrew this, which she said was a lot of fun. In this example, a log azimuthal projection transforms distances from a single point in a way that perhaps better reflects human perception and experience in the world. While I don't know also that either of these mid-century male scholars should be held up as any sort of feminist icons, we can talk about that, we do believe in the work we're trying to do that the importance of a view from somewhere is also something that we can try to represent using these kind of digital tools. So to sort of paraphrase Megan Kelly and Amber Boss's paper on reflexivity yesterday. Okay, so how do we get positions and distances out of Cartesian space and into some of these funkier projections, like the log azimuthal, or other nonlinear distance transformations? And then also, how do we do this in a way that's friendly for people who don't want to get stuck in the code? That was sort of our guiding question. And there have been actually some very cool digital experiments by cartographer Philippe Rivière in D3, you see on the left, and mathematician Matthew Rowan, who did this in MATLAB, of all things, which kind of blew my mind. So Rivière's is an interactive. This is an observable notebook. You can check it out. It's super cool. But without a data layer over this base map or a whole lot of customization on the map parameters. So we really wanted something that was kind of a working tool. So where people with spatial data that's in a CSV, a GeoJSON, shapefile, could upload it to a website, transform it interactively in real time, and then export it as something like an SVG to make more aesthetically pleasing down the line. So I was landing yesterday at CTAC when Tim Mecco gave his screenshot for the wind talk, but I thought that really captured, the slides I saw at least, captured the spirit of what we want to provide, which is a lightweight tool to help people get their data into a useful shape, not a finished designed product. So when we get to the demo, keep in mind, not a finished designed product. So for now, we thought about, well, what do we need to change to get these kinds of relationships and depict them? And we thought about two parameters in particular. So the distances between points in the input data and the data values at each point. And we thought about the different ways that we might transform these. Loosely, we have log, square root, great circles, kind of our starting point, and then we'll get into user-driven in a minute. So we started playing around in R to figure out how to accomplish this, and realized that what we needed to do first was to convert all of our lat-long pairs into polar coordinates, so great circle distance and bearing from the origin, using libraries like GMT and Geosphere, which which are very helpful. Then what we could do is transform these distances however we liked and reconvert back into Cartesian coordinates for plotting, which right now we're actually just doing in ggplot. So for those of you who are really into our spatial, you might be just like aghast right now, like ggplot, like what? But there is a method to the madness. You know, what we really care about is distance from a point, and what better thing to do that with than just a basic plot. So the kind of data that we can work with right now is explicitly relational. So there has to be a clear center for the map and a data variable that relates back to the center in some way. So in this case, we're using data on remittances to India from the World Bank. And so the radii of the points are the remittance totals on a log scale. And then the shading is the great circle distance, which helps give context for some of the more extreme distance interpolations. Okay, here we go. It's one thing to show you a screenshot of the interface when we can do it live. Oh, it's already up. Actually, I'm just going to mirror the display so I can do this. Okay, so this is our interface right now. You can see this is a shiny app running in R, which brings its own sort of, like, you get really used to working in R and all of its quirks, and then you go into Shiny in R, and like your brain is sort of rowing in two directions at the same time. But essentially what you can do is, by clicking any of these radio buttons, we can change, for example, the distance transformation. So we start out with great circle. We could really just start out with lat long, but that's essentially duplicated on the left here. This is just your gut check, like, did I use the right columns? Is this data even spatial? So you get that information. And then the default we have is great circle, so distance from a point on the geoid. But really, the idea for this is to do something more exciting. So for this particular data, you might decide that square root is something that you're more interested in. I'll show you in real time another data set where that's maybe a different relationship. So basically trying to figure out what the underlying spatial relations in the data and then have that guide your visualization. So this is sort of iterative process. So one of the other data sets we have is customer data of a local business in Merrimack, New Hampshire. Pretty random data set. But for this, you can start to see, and again, this shouldn't be any news to people who are economic geographers, but in this case, a logarithmic relationship is actually going to be much more appropriate. So we can see here the distances, all of these small kind of New Hampshire and northern New England towns contributing quite a lot of the visitors. But then as we get farther out, you see Baltimore, you see, where is that, Glendale, California, sort of in the farther tiers. And then you can also do things like change the square root, do the raw data values. I don't know why you'd ever want to do that, but we let you. Of course, it wouldn't be, a Silicon Valley adjacent project if we didn't have a dark mode. So we have a dark mode. Again, the design is very preliminary. But yeah, so the idea is that, any relatively low preparation is required for the CSVs to be read in. Here's another one showing flights from Chicago. And you can see logarithmic is sort of helpful, but actually maybe square root is a little bit better. And then this custom, this is something we want to really explore and make more data-driven and actually figure out a way to kind of detect what an appropriate distance transformation might be. But for now, the idea is maybe you as the user are the subject matter expert, and you have a sense of qualitatively or roughly quantitatively what is near and what is far. So if you say, actually the airports that are within 500 miles, that's what I care about being near, so I want to really show those cut points, and I can tweak basically sort of 2 points along that distance transformation curve. We experienced with like a more complicated Lagrange polynomial, but long story short is that we couldn't assure monotonicity, so we got all these really funky cubic functions. But this is basically just a stepwise function that's allowing you to kind of warp different features. So I think that's it for the demo part. Let me get back in here. Okay, great. So in the near term, based on what you saw there, we're trying to add support for some more complex input data. So including, first of all, getting out of CSV to add GeoJSON and shapefile, but also interactive selection of center points. So really there's no reason that we have to, we might have a data set where we have like flights from Chicago, flights from Detroit, flights from Miami are all columns. So why can't we just iteratively change the center point, and if we have enough data to follow that? Also choosing the data variable column. So if we have things on the remittance data, we might also have emigration data. We could put that together and just toggle that. So what else do we have here? Changing the visualization, and then obviously that export into something that's out of this clunky R land. So if anyone here is actually an R or Shiny wizard, please help us figure this out, because this level of reactivity has been a little bit tricky. We're getting there. Farther down the road, we'd like to add support for transforming polygons, which in theory, I say in theory, shouldn't be that different a workflow, because we'd just be treating each vertex as a point and going through the same process. Again, in theory, like we'll get there and see what happens. Also, since all of these distance transformations are variants of an azimuthal projection, we thought that in theory we could define them in proj4 syntax and then go back into a real GIS and project your coordinates there, which would open up a lot more capabilities. But again, this is starting to break our brains a little bit. So proj4 is another place we could use help. And then the other aspect of that is that what we're happy about so far with this kind of beta version is that it doesn't rely on GIS experience or knowledge. So in some ways we like keeping it in this kind of, screenshot for the win mode. And then we'd like to do something around adding isomorphic contours and surfaces in this view. That's actually sort of our original inspiration, was this idea of trying to get kind of data surfaces, not just point radii, but trying to interpolate into raster and then plot in ggplot. Again, it was like we're speaking 3 languages at once. So I think we still have a decent number of minutes for questions, input, feedback. We would love all of that. And then you can go check this out on GitHub. We would love pull requests, bug reports, feature requests, whatever you've got. Okay, thank you. I'll take questions now if you have any.
Thanks, Will.